Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. Today we are going to start a very important topic, in fact, a very important chapter of this course, and that is the turning effects of forces. Ladies and gentlemen, this is lecture number 25 of the Physics 5054 of GCE. Ladies and gentlemen, we learned in unit number 3 that forces have the ability to cause the motion of objects. Sometimes, if we are applying the force, it produces acceleration. Sometimes it produces deceleration, and sometimes when we apply the force, it changes the direction of that motion. In this unit, we will discuss the turning effect of motion. If you remember, we talked about the properties of forces, that when we apply the force, it can rotate a body. In this unit we will give a in-depth look to this concept. Ladies and gentlemen, why it is easier to open the cap of a bottle with the opener than by the finger? This concept used in this scenario is the moment of force. Ladies and gentlemen, moment of force, turning effect of force, and torque yield to the same concept. Moment of force is a new name given to the torque. Ladies and gentlemen, this moment of force have very vital role in our daily lives. For example, if we are opening the door, so we dragging that door from the knob, so it is producing a turning effect. Then if we are opening, then we are turning that knob in the clockwise direction and then opening the door. Similarly, if we want to close the door, then the key is rotated inside that knob and we are locking the door. These are all the concept of turning effects of the motion. Ladies and gentlemen, you may have seen that the driver of the car is rotating the steering wheel when he wants to move to the left or to the right. That is also producing the motion around a fixed orbit. So these are all the concept of the moments. One example we given is the opening of the wheel of the cap of the bottle. and the second example is that of the door, and the third example is of the steering wheel. These all example are, and all these turning effects are known as moment of force or torque. Torque is another name given to the moment of force. Uh, Ladies and gentlemen, the moment of a force. Next topic is the moment of force. The moment of a force. Uh, Ladies and gentlemen, the turning effect of the force about a pivot and its and is calculated by the product of the force F and the perpendicular distance d from the line of action of the force to the pivot is called moment of force. For example, if there is a wheel of bicycle, it is moving around a fixed pivot. So these forces on the wheel which is rotating it is called moment of force. And moment of force is mathematically equal to torque, and torque is always defined by the Greek letter ta, and that is equal to either R cross F, or also we can write it as F cross D. F is the force and D is the perpendicular distance from the line of action. Ladies and gentlemen, we will listen this word very frequently. So let me explain that what is the perpendicular distance from the fixed rotation orbit or pivot. This is a door and this is the knob of that door. Ladies and gentlemen, this is known as this dash line is known as the fixed orbit. This is fixed. This is not moving. In this case, this is also fixed. This is not moving here and there. So when we are applying this force, I am making it in this direction, but actually it is not downward. It is towards me, but I cannot draw it here. So I am writing this is F. And that will be like this, because when we are opening the door, so we are applying in this direction the force. But for your understanding, I wrote it here. And this is the particular distance from the point of rotation. In this case, the point of rotation are those hinges which we are seeing inside the door. So this is F and this is D. F cross D. If there is a force and there is perpendicular distance, then it will produce torque or turning effect or moment of force. So a torque is equal to F cross D. What is the unit of force? It is Newton. And what is uh, the unit of distance? It is meter. So what is the SI unit of moment of force? The SI unit of moment of force is Newton meter. Keep this in mind. If there is no need to memorize these things, how you will, because seeing the equation we can derive force is Newton and D is meter. So in this way you can memorize the unit as well. Ladies and gentlemen, uh, there are two types of there are two types of the moment of force. One is clockwise and the second one is anti-clockwise. The first one is anti-clockwise moment of force, and the second is anti. The second one is clockwise moment of force. I am explaining this topic because we are heading towards a very important topic, and that is coming in a few minutes. Uh, Ladies and gentlemen, if there is D and the force is upward, this is D and this is the force, so it will produce around a pivot. For example, this is a pivot point. So if you are dragging this, it will produce the anti-clockwise rotation and this will move in this direction. But in the second case, if there is a pivot point and you are moving it towards downward, then this is the D and this is the F. Then it will produce clockwise moment. I told you that I am heading towards a very important topic, and that topic is equilibrium. The body will be in equilibrium if clockwise rotation is equal to anti-clockwise rotation. If both the forces are equal, then they will be in equilibrium. Equilibrium is a very important topic, but first you have to clear the concept of moment of forces. Ladies and gentlemen, it is not only the force which is causing the rotation, also there will be a moment arm as well. This is called moment arm. So if D is not there, F is there, the magnitude of force is there, but the perpendicular distance, it must be perpendicular. If it is like this, 90-degree, then it's okay. If it is like this with certain angle, then it is not a perpendicular distance, so it will not produce the turning effect. Both the things are necessary. One thing more I want, we are opening the door, and if we are increasing the moment arm, then less force will be required to move that easily. If we are applying a force here and the knob is here and opening this door, so we have to, if this distance is smaller, you have to apply a large force, because to open the door you need the large force. If this is greater, then you have to apply a less force, and that is why I told you in the case of uh, that bottle cape opening technique, that we can easily open the bottle cape with the opener. Similarly, if there is a spanner with you and you want to open a tight nut, if the moment arm is larger, then you have to apply a less force to open that tight nut. But if you are having a small moment arm, then you have to apply much force on it to open it. That is why in the turning effect concept, this D is playing a very vital role. D small, force is larger. D larger, force is smaller. Both can be balanced when D and F are equal. To demonstrate this practically, you can see in the example, and this example is telling you that a student conducts the following experiment to feel the turning effect of a force as shown in the figure 5.6. And ladies and gentlemen, you can see that on the right side of this screen it is given, and also you can see it here on the whiteboard. I made it for you people to explain it, otherwise you can see on the screen as well. Number A part is saying if the weight W is placed at 15 centimeter mark as shown, find the moment of force in the case. Force is equal to, F is equal to W about the pivot, in this case the hand. Okay, ladies and gentlemen, let us come to the whiteboard, and they say that if the weight force is here, this is a 0 centimeter mark on the half meter rule. Half meter means 50 centimeter rule. 1 meter is 100 centimeter, but here we are having from 0 to 50, so half meter. Well, one thing you have to keep in mind that the mass of this meter rule is negligible. The mass of this meter rule is negligible. So for this purpose, the weight is placed which is W in this case, and that is placed at 15 centimeter. So in this case, D is 15 centimeter, which is equal to 0.15 meter, because the standard unit is Newton meter. So we need in meter and force in the Newton. Uh, Gentlemen, this is 15, but if we are, because from the pivot, if we are subtracting, pivot is this point, this hand is a pivot. So what is this D? So D is equal to 40, because hand is at 40 minus 15, which is equal to 25. From 40, if we are subtracting 25 centimeter, and that will be equal to 0.25 meter. Now W is a fix, which is 5 Newton. W is given as 5 Newton. So torque will be equal to, moment of force will be equal to F cross D. This D is the perpendicular distance towards the pivot. So it means it is displacement. Force is W, and that is equal to 5, and D is 0.25. So you have to write Newton meter here as well. Many students are committing this mistake by not writing the unit, so then the examiner can cut your marks. So make it your habit to write the unit as well. Now when we multiply this, the answer is coming to be 1.25 Newton meter. The next part of this question is saying that he then shift the same weight W to the 5 centimeter mark. Then he shift this weight to, they are shifting it to 5 centimeter mark. So they are shifting it. For example, here I am making it with another color, because he shift this mark to this 5 centimeter. Now they are saying that, and find that it is more difficult. The student is find that it is more difficult now to maintain the half meter rule in a horizontal position than before. For example, in case number A, this was case number A here. Why it is difficult to now maintain the balance of this pivot by hand? You have to put more force here. If it was here, then it means that you had to put less force. Now let us solve this equation here, and they are saying in this case, what is the D? 50, because the hand is at 40, and now 5. In previous case we subtracted 15 from 40, but in this case we have to subtract what? We have to subtract 5 from 40. So it will be equal to 35. 40 minus 5 is equal to 35 meter. W is equal to F is equal to W is also a vector quantity. So F, and that is given as 5 Newton. That is fixed. It is not changed. In this case, moment of force or torque is equal to F cross D, and in F cross D we are putting the value 5 into this is centimeter. So when we convert it to meter, it will become 0.35 meter. So we have to put the value of 0.35, and that will be Newton meter. So when we calculate this, it will be 1.75. 1.75 Newton meter. Now the question is saying that why it is difficult to maintain from these two parts. If the distance between the pivot and the moment and the weight, where the weight is hanging, is more, then you have to apply less force. So from these two situations, 1.25 Newton meter and 1.75 Newton meter, you can observe that here we need less force and here we need greater force to maintain the stability, the equilibrium. That is what I was saying. Let us explain it in this door scenario, and I explained it earlier that if this distance is less, you have to apply larger force to open the door. But if this distance is greater, then you had to apply a very small force. So in this case, this force is less and here the force is more. Similarly, in this case is the y portion of part number B. Since moment of W when the weight is at 5 centimeter marks is greater than that at the 15 centimeter mark, it means that the turning effect at the 5 centimeter mark will be felt more strongly. Ladies and gentlemen, that was an explanation that how F and D changes the force, the application of force for the turning effect. Uh, Now we observe that in this example that for moment of force, not only the magnitude of the force, in this case W, is required, but also the perpendicular distance is also necessary. You have to take in account that as well. So both force, the magnitude of force and the magnitude of perpendicular distances are required for the turning effect of force. Ladies and gentlemen, that was the basic concept about the turning effect of forces. In the next video, we will come with new techniques. So keep in touch with this channel. We hope that you have enjoyed this lecture. Thank you very much for watching. Please subscribe if you haven't yet subscribed my channel. and press the bell icon. Thank you very much. Allah Hafiz.